Good evening. It is Thursday, July 20th, 2023. This is Jason Horak reporting on the ongoing adventures of the Dodge Daytona electric vehicle. So what we are looking at here is the charger buddy that I pulled out of the car this evening to take a look at an issue that has cropped up that is more of a cosmetic problem than a functional one, but one that I wanted to deal with while I'm going through and kind of fixing up the rest of the car and making it nice and show-worthy once more. So the issue is this little JLD5740, I believe it's a JLD5740 TV model number volt meter, that is the brains behind the whole charger buddy unit, has some cosmetic trouble. The camera, I believe, is picking up that the polycarbonate or plexiglass little plastic cover here is warped and deformed, which occurred, I believe, because of the intense sun beating through the hatchback glass in my car onto this unit, and it just over time got so warm that it caused it to kind of shrink a little bit here on the side and sort of deform and warp in there. It still works just fine, but doesn't look terribly great, and when I'm showing off the car and the charger buddy to people, I don't want it to look like it's been melted. So the other issue is that there was a little door here originally that covered the buttons. That door broke off during one of my previous attempts, either wrangling the device around in the car or when I was installing the meter in one of the videos. I can't remember, but either way, that's been gone for a while. And there's the buttons here are like a circle and then a going that way button, like a play button almost, and then this one's a down arrow, and then this one I believe is an up arrow. This one doesn't work. This doesn't seem to do anything. The down arrow does seem to work in some cases. You can kind of hear it click, but this up arrow button doesn't seem to work. So again, the meter's just got some issues. It does, again, still function. It does its job, but I want to replace it just for cosmetic reasons. So anyway, you can see that the two different LEDs on the side are on, indicating that both relays are currently engaged. And this makes sense because it's reading 0 volts. It's not plugged into the battery pack at the moment. And I just got it plugged in with my 110 volt adapter here to the regular household main plug, just to power it up and be able to access the meter. So this will not engage and make this a live outlet until this reaches the set points that are programmed into this thing, and that it has a battery pack showing a voltage, I believe, higher than 100 volts, but we're going to check that in a moment. Anyway, so just what we're going to be replacing that with is this brand new JLD5740 TV digital voltmeter. I'm not sure if the camera is actually picking out the text on that, but that is what it says. This one has an operational door on the buttons. Very exciting. Also has the plastic cover, not all warped and deformed. And it has the same screws in the same order, and labeling and all that kind of stuff. Actually, here on the bottom, make sure I got it flipped over. It's this way. So all of these are exactly the same setup as this meter because it's the same thing, just a more recent version, or more recent purchased one anyway. So this one I got on eBay just a few days ago from a place called Cold Fusion X. Also lightobject.com. I'm not sure if the meter's light object or the place selling it is light object. I'm not sure, but either way, this is the meter, and it was a whopping $30 on eBay. So that's what the page looks like on the eBay sales thing. And anyway, came quickly and should replace this guy as a one-to-one replacement for what was there before. Okay, so before I go ahead and remove this old meter to put in the new one, I want to go through the configuration and just show what each of the settings were on the old meter so that when I'm setting up the new one, we've got a handy reference. So first off, we go ahead and we hit this round button for the menu or configuration mode, and then we hit the right arrow button. And normally you'd hit the up arrow to go to number 1, but since my button is broken, we're going to go ahead and hit the down arrow to get us down to number 1. And then we hit the circle again for the menu. And now we're into the configuration settings for the 2 relays, upper and lower, the 1 and 2. And so all this does is you have a high and low point. So high point of relay number 1, low point of relay number 1, high point of relay number 2, and low point of relay number 2. And it's kind of odd how you configure these things. I'm not really going to go into it. I've documented it in a previous video. But essentially, your high point is actually where you want your batteries to settle for the first relay. So that's 196.6 for 59 cells of lithium iron phosphate CALB cells. And the L1 is our fully charged point, 206.5. Again, you divide that by 59 and you get your voltage per cell that you are charging up to. So it will turn on this little relay right here, the top one, anytime the voltage is below 206.5. As soon as it hits 206.5, it's going to kick that relay off. And then it will stay off until the batteries hit 196.6. If they go below the low of, which is set to the high one, below that value, then this relay will turn back on and it will stay on until it hits that 206 again. So that's kind of your hysteresis of charging up to full, shuts off the charger, lets it settle down to 196.6, and then turns it on again, and so on and so forth. But the nature of lithium iron phosphate cells is that they will hit a point when they're at rest that is going to be this or higher, and then they're going to stay there when they're fully charged. Once you start drawing a load on them, you're running your DC-DC converter, you're running your lights, you're doing whatever, it may drop below this, in which case the charger would kick back on if it's still plugged in. And that's kind of what this whole range is. So then we have the H2 and L2, which is again for the lower relay. So you'll note that the lower relay is on. Well, the reason why it's on right now is that we have no voltage. There's nothing being fed in here, which means that we are below the minimum voltage that this is set to. And I believe that's H2. We're going to find out here in a second. So 50 volts is what it's set to. So 50 volts is our minimum, at which point it will kick this relay on, and our L2 is our maximum, at which point it will kick this relay off. So if we hit 100 volts or higher, this bottom relay shuts off. And that's what we want. We want the top one to be on and the bottom one to be off to energize this particular outlet, which then powers on the charger. Idea being that anytime that there is nothing hooked up, the charger buddy will prevent the charger from turning on because this relay is in the on position. Again, kind of backwards, kind of weird, but that's how I wanted to set it up, so that if the main pack cutoff, the big red button in the front of my car, is turned off and there's no voltage going to the charger, or the charger buddy in this case, then it will not allow the charger to be powered up regardless. And that protects the charger from being accidentally turned on when the pack has been unplugged or that big maintenance switch is shut off. So it's a little bit of a protection feature. It also, because I'm using that auxiliary unit that's attached to the other end of this cable, it physically disconnects the charger from the pack. Anytime when this unit isn't powered up, it's not plugged into the wall. So when I'm going to plug it from the wall, it removes power from this, it removes power from that auxiliary unit, and thus disconnects the battery pack completely from the charger, and that keeps it from having any kind of spikes and weird voltage coming from the controller and the motor back through the wires and causing a problem with the charger. In my case, the PFC50 charger that I have gets a really loud whining noise if it detects that just kind of current in the lines or voltage spikes or something. It's probably a capacitor or something in there that just reacts with that. It doesn't hurt it, it's fine, but it makes an annoying noise. And so by having it completely disconnect is a nice feature for my setup. But regardless, the important thing is for those two relays, those are the settings that I've got it set to, the 100 and the 50. So again, if it's anything over 100, the charger is going to, or the relay is going to shut off, which then allows it to function and charge the car. Anything below 100, it's going to turn this relay back on again and cause it to not to allow the charger to function. So anyway, that's that setup. The only other setting of note in this menu is, again, we go over here, it's going to be a 36. Now, I didn't figure this stuff out. This is all from Jack Rickard. Oops. Try again. That he figured this stuff out, documented it really well, and mostly for the JLD404 meter, which has got the same menu configuration as this thing. So the PUL, so it's file dot PUH and PUL. So the dot is just the number of decimal places that it shows on the meter. The H and the L they determine the it's kind of a scaling factor that, you know, this meter can read up to 500 volts. It's got a 500 volt connection as one of the terminals on here, and depending on which one you hook this up to, you either have, it looks like 1 volt, 10 volts, 100 volts, or 500. So if you're on the 500 lead, then it has a bigger range of 0 to 500. You have to kind of dial it in a little bit to make sure that it matches your particular setup. And what I found was, in order to make this meter, this particular one, match my JLD404 in the car, just so that the voltages showed the same thing, when the pack was hooked up and stuff, I had to kind of adjust this with a little fudge factor to 562, so like 500 volts of actual input. Like if it sees 562, it would show 500 on the meter. I believe that's how it works. And then you have the L, which is just set to 0. So when it shows 0, it's 0. So it's basically a range of detection by the device that goes from 0 to 562 on that 500 volt pin. And it will map that, it'll kind of squish the numbers to be 0 to 500. And so it's kind of a weird thing, but essentially you might have to play around with this number in order to make it match, you know, your multimeter or whatever tool you're using to do your measurements with. Just because voltage in this kind of range, it tends to drift a bit, and so you kind of have to dial it in for your particular, the range that you're working with. So for example, this particular meter, it may not be terribly accurate at, say, 12 volts when you've got it plugged into the 500 volt pin, but it's more accurate when you're at higher voltages than the 100 volt maximum that this one has as the other pin. So it's kind of a funky electronics thing, and it's sort of like a calibration, I guess would be the right word for it, in order to make this meter show the same number or very close to the same number that my JLD404 showed. One other thing about that that's kind of interesting or weird is depending on the temperature, that number will fluctuate, that reading. For example, when this meter was in the sun, as it obviously was with the warping that happened and so forth, this meter would sometimes show a higher value or a lower value than my JLD did, just based on the temperature and location in the car by a few feet, but one in the sun and one outside of or not in the sun. So anyway, that's what that number 36 menu is for, is you just kind of dial it in to make sure that the number that you're seeing matches the number that your multimeter shows or your other measurement devices. So anyway, that's all there is to it. In theory, once I get this all hooked up, we should have the new one installed. Both these lights will be on because the voltage is below that 206 point, which makes this one turn on, and it is below the 50 or 100 volts on the second set point, which is making the second one turn on, which actually cuts power to this at this point. So anyway, not sure if that was as clear as mud or not, but there you go. Okay, since I have the charger buddy taken apart, I'm going to quickly go over how the JLD5740 meter is wired in, mostly as a refresher for myself, but also for anyone watching this channel who is going to be wiring one of these things up. So what we've got is on pin number 1, it's right here, and this is the positive voltage incoming low voltage which runs the meter. And then pin 2 is the negative incoming voltage. So this is hooked up to a Dell power supply from a laptop that is currently putting out, I believe, 19.5 volts. This particular meter can run at a pretty wide range of input, so it doesn't really matter. But this is our positive, this is our negative. The positive has a little jumper that goes over here to pin number 15. Now, pin 15 is the common relay, or common pole of that relay. And then the negative goes to number 12, pin number 12, which is the common of this second relay. And then what it's got is when the relays turn on, they shift this way. So in this particular case, for the positive, the 15, when it's on, connects 15 and 16 together. And in this case with the 12, so 12 and 13 would be connected together when it's on. 13 is not used. So when it's off, this one would connect pins 15 to 14, and this one connects pins 12 to 11, which completes the circuit. So again, this one needs to be off, and this one needs to be on in order for it to turn on these two contactors, which are what's wired in with these right here. Also wired into the on of the low voltage is this green, and it's like a striped green and white wire, and this is a solid green wire, and these go in this Ethernet cable out to the Charger Buddy auxiliary unit to engage the positive and the negative for those two relays that are in that box. So anyway, we've just covered the whole bottom row of how that's wired in, and we covered 1 and 2. And so the brown wire here with the red is the high voltage sense wire that goes to the battery pack for it to take the reading from, and the kind of orange and white striped one with the black lead is the negative for the battery pack sense wire, high voltage. So those particular colors were picked because they're far apart on an Ethernet connector. They're on either end of the cable. And so you're kind of keeping your high voltage wires as far apart as you physically can within a plastic RJ45 connector. So anyway, number 4 is the positive and number 8 is the negative. And so number 8 is technically considered the common, and then depending on which one of these, whether it's 4, 5, 6, or 7, determines which voltage range you're measuring at. So if you put it into number 5, then it would be the 100 volt, and it would be more accurate from 0 to 100 volts, versus this one, which is 0 to 500 volts, but is a little less accurate because you're measuring a wider range. And then it kind of goes down from there to 10 volts and then 1 volt for the last two. Alrighty then, so now we have the Charger Buddy with its brand new meter all installed in the car. As you can see, I have my Manzanita PFC50 charger, which is the much larger version, because my PFC40M charger is currently broken. I'm not really sure what's going on with it. It might be a blown fuse again, or possibly something inside came unsoldered again. I'm really not sure. I may need to send that out to the state of Washington to get it repaired, but I guess we'll see. Anyway, this is the charger that I'm going to be using for the foreseeable future, and it does take up a lot more of my trunk space, but what are you going to do? So anyway, this is the Charger Buddy in here, and I wanted to show some interesting things that I had forgotten and needed to set up when I got this in the car. So let's go ahead and open this little door here. So the first thing is we need to go to configuration menu 36, which I kind of showed before, and that one is the one needed for setting the sort of fudge factor of how bad the meter actually reads the values and stuff. So with this particular meter, I have it set to 484. So this is like what max a 500 volt reading would read. Like, so if it saw 484 on the meter, that would really mean 500 volts if it actually had a 500 volt input. In my case, I'm at about 196.6 volts, but this meter with that setting, let's get down here to end, is showing 197.3, whereas my JLD404 is showing 196.6, 196.5, right about in there. So it's a bit off still, and this is with it being significantly tweaked at the 484 level. I'm okay with this one being a little bit higher though. So again, this is 197.3. That one's showing 196.5, and that one actually matches the 196.5. What my multimeter says when I hook up the leads right to the pack. I get 196.3, 196.4. So it's very, very similar with what this particular meter, this X-Tech Instruments meter, reads at those locations, and those are the same locations, the positive and negative for the pack, that the other two things are reading from. So everything should be the same. It all should be 196.3 or 4, and the JLD meter says 196.6, 196.5, and this one shows 197.2. And again, I'm okay with that. I can try to dial it in a little bit more to try to get it closer to the 196.6, but the issue is that this is what controls the charger. So if it's reading a bit high, what that means is that it's going to shut the charger off a bit early, which I'm okay with. In fact, that's preferable. I don't want to overcharge the pack. I would rather undercharge it slightly rather than overcharge it. So we're going to leave it as is, and maybe I'll tweak it a little bit more in the future. I'll try to dial it in a little closer, but having it read a little higher, I'm honestly completely fine with. So anyway, that was the first thing, was the the number 36. So the other thing that I needed to show you was number 89. And this is the one that I completely forgot about. And I had to look up some documentation made by the late, great Jack Rickard. And this is the P-SN setting. It's the only one in the list. It's end in that. And what that means is this is the voltage sense leads. Like, which screws do you want? Are you getting your lead or reading from? Is it the the 10 volt? Is it the 100 volt? Is it the 500 volt? Whatever. You have to pick here. And there's a nice little chart that Jack put together that shows it. But 0 happens to be the one that is for 500 volts. So anything that's above 100 volts and lower than 500 volts, which is my pack, has to be that. If I pick number 4, which was the default on this sensor, we are seeing 0 volts. And that's what happened when I first plugged in the meter. And I plugged in the charger buddy to test it. I was like, oh my gosh, it doesn't work. It's not seeing the pack voltage. What's going on? Well, it just was, I forgot to set this so that it was using the 500 volt lead, not the 100 or 10 volt or whatever it is that's actually looking for a voltage on. So anyway, we just got to go here to number 89. Boop. Boop. And enter, and we hit enter again, and we change this to a 0 so that it'll actually read from that 500 volt thing. And end. And as you can hear, it actually kicked on the charger. And that's because the volt, or the pack, had fallen low enough that it was below the minimum, which I believe we have set to like 196.5. Just because it had been sitting there for a while after it had charged and the pack had settled. So we're actually going to see a full cycle here, which ought to be kind of fun. It shouldn't take too long because the pack is fully charged at this point, or as fully charged as I'm going to make it. So right now it's I'm not sure if the camera makes it out or not, but the JLD404 is showing 202.6. And the charger buddy is showing 204.3 now. Everything's, rising because we're pumping in, I believe, about 40 amps when all said and done, coming out of this charger at this voltage range, all that good stuff. But yeah, so when the charger buddy gets to 206.5, which I believe was our set point, it's going to turn off our charger. If I can get the charger and the JLD and this all in the shot at the same time without too much shaky cam. So we're at 205.6, 205.9. And you see the voltage kind of goes up and down. That's normal as the charger kind of gives it a little more juice and then it lets off a bit. And there it is, 206.5. It turned off. And the charger shut off, and now we're in that decreasing voltage for the battery settling phase. And yeah, so once again, the JLD404 is showing 199.4, 199.3, whereas the charger buddy is showing 201, 200.1, 200.0, 199. So yeah, it's it's still showing higher than what the JLD404 shows, but again, I'm totally cool with that. So, this takes about 20 minutes, give or take, for the pack to settle down to about the range where it might kick on again for another little touch up. But anyway, it's not doing any kind of hysteresis on the charger. It's not like turning it on and off and on and off and on and off really rapidly. And it's exactly how I wanted it to work. So good job, Charger Buddy. Way to go. Yay.